Okay, we are back once again. My last video was regarding the functional groups. Now, if you can remember, in my last video, we have spoken about halides. Halide means halogens. Chloro, bromo, iodo. Okay? We have done about alcohols. Alcohols ends with ol, ol, ol. Aldehyde, dash, CHO, they end with al. COOH, carboxylic acid, they end with oic acid. All these things I have done in my last video. Next, today we will discuss about ketones, ONE, and ethers, oxy. Okay? So these are the two functional groups that was left to be discussed. We will discuss about this right now. So these are things. There are many more functional groups. In fact, you don't have anything in your syllabus. You have got just few. Even you don't have ethers also. After ketone you have got. So make sure you study these things and practice these things. Now one thing, let me tell you, something is not mentioned about the structures of this. That aldehydes, make sure you try to write in this way. CHO, carboxylic acid, try to write in this way. COOH, okay? Try to write down the structures in this way. So this will be helpful for you. Now we will discuss about ketones and ethers. After discussing about ketones and ethers, we will finish up with the functional groups and move on to the next part of the chapter. Okay. Now, what are ketones? As you can see, ketones has got a structure like this. Ketones, Ketones. They are known as ketones. Why? They have got a structure like this. What is this empty? Here, the alkyl group is attached. Either it can be same or it can be different alkyl group. If I can tell you the examples, I'll draw the examples of this alkyl group. You will understand it clearly. When I talk about ketones, it can be like this. In place, it can be CH3 dash C double bond O dash CH3. So these are alkyl groups. So this is same. If it can be like this, CH3 dash C double bond O dash C2H5. So two different alkyl groups, two same alkyl groups over here. Okay? So ketones has got, this is the functional group of the ketone. Okay? So you understood about ketones. Now let us come up to ethers. What are ethers? Ethers, don't get mixed up with ketones and ethers. Ethers are compounds where two carbon atoms are joined by oxygen. You can see in between oxygen is there, and here lies the alkyl group. So you can write R-O R-. This is the functional group. These are known as ethers. Now, ethers has got functional group like this. Okay? Now, about the naming, oxy, one of ketones ends with one and ethers with oxy, the naming we will discuss separately in ICSE nomenclature. So, dividing this functional groups, there is a chart in your book. So, make sure you study the chart and get habituated with these functional groups. So, now we will move on to understand about saturated and unsaturated hydrocarbons. When I have discussed even the difference of saturated and unsaturated hydrocarbons, I say saturated hydrocarbons show only one type of reaction and unsaturated hydrocarbons show only one type of reaction. So we will understand saturated and unsaturated hydrocarbons show the type of reactions. Let's come up to saturated hydrocarbons. Saturated hydrocarbons. Now, I told you, saturated hydrocarbons show what type of reaction? Substitution reaction. Shows substitution reaction. Now, what is substitution reaction? Let us understand. Let us take a simple example of methane. First step is this. Methane, CH4. Okay? If it reacts with chlorine, what will happen? The first step of reaction will be CH3Cl plus HCl. The reaction does not stop here. It carries on in the next step. The second step will be CH3Cl. This CH3Cl further combines with another chlorine molecule to give here light is required CH2Cl2 plus HCl. Third step will be CH2Cl2 plus Cl2 further reacts to give CHCl3 plus HCl. Fourth step, CHCl3 further reacts with Cl2 to give CCl4 plus HCl. Now you did not learn all these things. You don't have to learn these things. If you know the mechanism of action, it becomes very easy for you to do the reactions. Now let's see how it takes. This is the overall reaction. The reaction does not stop here. It carries on and on and on until all the hydrogens are substituted. Observe, here there are 4 hydrogens, here is 3. That means one hydrogen is replaced by one chlorine atom. One hydrogen is replaced by one chlorine atom. Second step, another hydrogen is replaced by another chlorine atom. See, the number of chlorine increases, hydrogen decreases. Third step, one more hydrogen is replaced by another chlorine. So chlorine increases, hydrogen decreases. Fourth step, all the hydrogens are replaced and ultimately no hydrogen is left. So what is this? The chlorine is taking the place of hydrogen. So this is known as substitution reaction. Let's see how it takes place. The mechanism of action. Let us see the mechanism of how the reaction takes place. See, make sure you don't learn these things. If you try to learn, you forget. It's better you practice doing it, you will understand it better. Now, for the first molecule, CH4. This was CH4. It reacted with what? Chlorine. For our easiness, we will write this one as Cl-Cl. Okay, right? Now in presence of sunlight, what happens? First, this bond breaks. One chlorine comes and attacks this hydrogen. One chlorine atom comes and attacks this hydrogen. So what happens? The chlorine comes and takes the place of hydrogen. Right? Now the hydrogen is pushed off. This hydrogen goes and combines with this and forms HCl. Got it? These hydrogen goes and combines with this to form HCl. This is the first step. Second step, what happens? Second step, this comes. This one comes over here. Right? Now, one more chlorine, Cl-Cl, bond breaks. The chlorine goes and attacks this hydrogen. Hydrogen is pushed out. What happens? Hydrogen, chlorine over here, and then HCl molecule is formed. So these hydrogen goes and combines with this. These goes and combines with this and forms this HCl. So in this way you can see the hydrogen is replaced by this chlorine. This hydrogen is replaced by this chlorine. So we are calling this one as substitution reaction. Now this will carry on how long? As long as the entire reaction, all the hydrogens are not completely replaced by these halogens. Got it? This is also known as halogenation. So it will carry on the second step. The third step, what happens? In the third step, I don't have trees over here. So the third step, let me show you the third step also. In the third step, what happens? Hydrogen must be here, one chlorine is already replaced, another Cl2 comes, Cl-Cl, these breaks, this chlorine goes and attacks this is pushed out, ultimately leading to the formation of Cl, Cl plus HCl. Got it? Fourth step, what happens? Once again, this will come here. Cl, hydrogen is over here, combines with another chlorine. So Cl breaks over here. This goes and attacks this. This is pushed out, ultimately leading to the formation of this Cl. So all the hydrogens were replaced, leading to the formation of HCl. So until now, the entire hydrogens are replaced, this will carry on. This type of reaction is known as substitution reaction. Clear? Understood? Substitution reaction. Now we will understand about addition reaction. Now I told you there are only two types of reactions. All saturated hydrocarbons show substitution reaction. All saturated hydrocarbons show substitution reaction. Now let us understand about a specific type of reaction, that is addition reaction. Unsaturated hydrocarbons. What type of reaction they will show? Addition reaction. So they will be showing what? Addition reaction. What is addition reaction? Let us see. Suppose this is a double bonded compound. Right? It reacts with chlorine. This leads to the formation of That's all. Addition means this gets attached to this. How it takes place? This is a double bonded compound, right? A chlorine comes over here. So this is combining with this. So what happens? This bond breaks. This combines with this. And this combines with this. See? Understood? I'll do it once again. Suppose double bonded compound combining with, say, bromine, Br2. What will happen? So Br2, I can write Br dash Br, means Br with the bond Br. So first, this bond breaks, this combines with this combines with this. Got it? Oh, so this is known as addition reactions. So in addition reaction, nothing else, I will do it in very easy say, none of the hydrogens are replaced. There is no removal of the atoms. So if I write out it in the condensed form, C2H4 plus Cl2. What is the molecule forming? C2H4Cl2. None of the hydrogens are placed over here. The chlorine just comes and takes place. But observe something. The double bonded compound converted to a single bonded compound. So in an addition reaction, if there is a double bond, it converts to a single bonded compound. Now if this one reacts with chlorine, they will show what? Substitution reaction. Now if this reacts, this will show substitution reactions. Got it? So the moment it becomes a single bonded compound, it will show substitution reaction. Even a triple bonded compound. If I talk about a triple bonded compound, suppose it is like this. It is like this. Triple bonded compound. What will happen? Let's see what happens. First of all, this is what happens. First step. Step 2. This comes over here. Further reacts with chlorine to give what? Bond breaks. Cl, 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 hydrogen, hydrogen. So triple bonded compound converted to double bonded compound, then the double bonded compound converted to a single bonded compound. I hope you understood. So these are addition reactions. These are addition reactions. There is no replacement of the hydrogen atoms taking place. So we understood about two things. We understood about substitution reaction. We understood about addition reactions. Okay, so let us keep it up to here. The next thing we will discuss about ICSE nomenclature. We will discuss about next class. We will discuss about what? IUPAC nomenclature. Make sure you understand this one, IUPAC nomenclature. Okay? The next class we will discuss about IUPAC nomenclature. So till then, make sure whatever is taught to you, you revise. If you do not revise, you will not understand and you will forget it very soon. Okay? Thank you. Thank you very much.